And now I introduce a little bit our speakers from India. Hello, Savita and Shivam. Savita má veľké pracovné skúsenosti s verejnými, ale aj súkromnými cloudami, ako sú Kubernetes, Native, Service Mesh a iné. V súčasnosti svoj full-time venuje Tekton CD a projektu. Shivam, rovnako ako Savita, pracuje v Red Hat ako softwarový inžinier. V Indii to už som hovorila. Vo veľkej miere prispel do Tekton a Openshift Pipelines as Code. A dnes si vzali spoločnosť spolu na starosť tému Untitled CICD with Tekton and ArgoCD. Shivam and Savita, please take over with your presentation. Thank you.
Thanks a lot for the nice introduction. I'll quickly share my screen. Hello everyone, welcome to KCD 2022. Today we are going to talk about how we can unleash CI/CD with Tekton and ArgoCD. A little bit about ourselves. I'm Savita from India, working at Red Hat, and meet my colleague Shivam. He is also from India, working at Red Hat. You guys can find us on Twitter, LinkedIn, Slack, GitHub. The informations are provided here. Moving on, this is the pretty much agenda we have it for today. So basically, we are planning to cover overview of Tekton, different projects which are present in Tekton, and among those projects, we are mainly focusing on pipeline and triggers project concept and with a live demo. Then we will see a high-level overview of ArgoCD and one of the important custom resource application of ArgoCD. And then finally, we have an end-to-end demo where we will show how we can integrate both Tekton and ArgoCD and how with the help of that integration, how we could be able to build and deploy on a multiple clusters. Moving on. So let's understand a little bit about Tekton. So Tekton is a open source project based on Kubernetes. It provides a continuous delivery and continuous integration. It also helps end-to-end application building, deployment, and development. And we used to call it as a build, and later it got separated from Knative and became an individual one. Now today we call it as Tekton. And it was started by Google, Red Hat, IBM, Pivotal, and few many other companies. And now today it is part of a CD Foundation. So Tekton is basically used by developers who write their CI/CD for their data, and also by the platform administrators who develop CI/CD for their organization, so that their developers or anyone of the organization can use it. So this is a pretty much overview about the Tekton. Moving on, let's understand a different projects which are exist in Tekton today. So even initially when Tekton started, it was very small, but now as the time goes on, it became a huge org kind of thing, and now it has a multiple sub projects. So among those projects, we are focusing on few major one which actually used by many users. So let's understand one by one each of those. So we have a pipeline. So basically, it provides a declarative way of declaring the K8s resources to write the CI/CD pipelines. And we have a triggers. And also pipeline is a core project of Tekton. I mean, most of the APIs resides under this pipeline project. And we have a trigger. So basically, if you want to do automation and if you want to deploy the pipeline resources dynamically based on some events, so in that case, we will make use of trigger project. Moving on, we have a CLI. So it is a command line interface which helps us to interact with the Tekton. And similarly, we have a dashboard. This is a kind of, it is a web-based UI. So like the way we have a CLI which interacts from the command line, the dashboard will help us to interact through the web-based things to interact with the Tekton. It could be from pipelines, triggers, to any of the component we can interact via dashboard. and then we have a catalog. So basically, like if you take an example of Jenkins has many plugins, right, which we can use and unuse. Similarly, what Tekton has decided to start a catalog project where number of users from different company with different scenarios, they will write task and put it in this repository catalog, and anyone can use it from here. I mean, most of the task, single entity of the task will be added in the catalog. So basically, if I want to say in one term, catalog is a project which contains a number of tasks which are reusable kind of thing. And we have a hub to, it's again a web-based platform which which shows the information of tasks which are present in a catalog repository. So basically, web helps us to decide which task is more popular, which task is used, and how many stars are given. So based on those information, we can use the task. So maybe like how we could able to use task from this catalog repository, we will show in the live demo. I mean, today in our demo, we are using most of the tasks from the catalog repository instead of writing from the scratch. Then we have a operator. So we all know that operator helps to do day one and day two operations mostly. So here also Tekton, as it becomes bigger and bigger, the installation is kind of a need to think a lot if end user want to install it. So we provided a operator which helps us to install the entire Tekton in a few clicks. So basically it helps to do manage day one and day two operations. So this is a different projects which mostly many of the users use. So moving on, let's understand a few of the concept and core resources of Tekton pipeline project itself. So here, similar to like Kubernetes, we have a container deployment service pod. Tekton pipeline also has its own concepts and few resources. So we have a task pipeline, task run, pipeline run. These are the resources. When I say resources, these are the custom resources which is provided by Tekton pipelines. And we have a step, workspace, result. These are the concepts which we use when we write these resources. We will show how these are interrelated in a live demo, and as well as in the next slide where I will just explain high level things of these concepts. Moving on, so instead of showing in this way, I just want to explain those concepts in a diagrammatical view so that it will be easy to understand how they are interconnected with each other. I'll take a scenario of cloning the code, building the code and image, and then pushing that image to the registry, and then finally getting the digest. To get the digest, it means in order to make sure push is success. And then finally, I'll deploy that image using kubectl. So you can see that these are the multiple stages I have done when I want to do these kind of operations. So like in Kubernetes, container is an entity which does some operation and terminate, right? So similarly, in Tekton pipeline, we call as a step. This is not a resource, but it is a kind of a concept or object kind of thing which we used inside a one bigger resource. So I'll come to in a minute. So before that, I just want to say that step is a entity which does some operation based on the provided information. So when we say information, it could be like environment information, image information, argument information, volume information. It could be anything. So it as I said, step is exactly similar to container. So it accepts all those informations which container expects. So now, like you can see, I have a step kept here and 3 step here and 1 step here. So as entity, we need to club these steps together to form an entity, and that we call it as a task. So basically, task is a custom resource of Tekton pipeline, which helps to manage multiple steps together and execute those steps sequentially. Like if I have multiple steps, it executes build first, then push, then digest. So this is something managed by task itself. and then I have a task called deploy where we will do the deployment. And the output of one task can be given as an input to other task. So when if you remember in the previous slide, I explained about the workspace and results. So these are nothing but the concepts which we use for input output operations. So workspace is nothing but kind of a storage where we store output of one task in a workspace, and that workspace give as an input to the another task. So to handle input output operation between multiple tasks, we use workspace as well as results. So these are the two entity in Tekton pipeline. Now you can think like, why I have kept as a three different tasks. I can write as a single task with all these steps clubbed together. I can do it. There is no issue. But I want to show one single task which is a reusability, right? So let's suppose I have a scenario where I just want to clone the code. Okay. So in that case, I can just straight away use this task from which was checked out somewhere, and I can use. So that's the reason. That is the one of the benefit of task. So basically, write a task which will do one particular job so that multiple users can use it. So let's suppose I will write a task called clone, but after writing, I will push that task to a catalog repository. And like later, after 1 month or after few days, some other user can easily use that task. The other user knows using it. So that's the reason I always prefer to write a single task which do some preferable work so that it can be reusable. That's the one of the benefit. Now to run this task. So till now, when I apply this task YAML on the Kubernetes cluster, it's just a static entity. It won't run it. To run this task resource, we have another custom. So basically, task run is an runtime entity which helps us to run these tasks. Now I want to combine single object, and we call them as a pipeline. So pipeline is a resource which contains multiple tasks, and pipeline knows how to conduct this task. So maybe in the live demo we will show how the tasks execute one by one on what basis. And again, this pipeline entity and this pipeline, we have a resource called pipeline. So a runtime entity which instantiate this pipeline. So till now, we see the theoretical part of these concepts and resources and how they are integrated with each. Now, I would like Shiva to forward and show us the live demo, how it exactly looks like and how our pipeline template looks like and how we could able to run the pipeline run. Shivam, over to you. Thank you.
Thank you, Savita. I will just share my screen. Okay. So we saw the Tekton pipeline concept. So we just try out the concept and then see how the pipeline would run. So for the demo, we are using an application, which is a news demo application. It's a simple application which you can search for news. Well, there is nothing quite complicated. So I have deployed this application on the cluster. So I will just, and we have another repo where we keep configuration for the CI/CD. It is not required to have two repos, but we are like having the code at one place and the configuration at one place. About the cluster, so it's an Openshift cluster. It is not required for the demo to be performed on Openshift. You can use any Kubernetes cluster. The only thing which would be different is for Openshift we are creating a route because it is easy to expose. You just need a Kubernetes cluster where you can expose something to outside. So basically you just need ingress. So for this demo we are using Openshift. So for the demo, so this is the configuration repo. In this we have the application configuration, the namespace deployment app. So I have applied this on the cluster, as you can see here. So there is a deployment, there's out, and the app is working fine. Now we want to set up a pipeline which would fetch the code from here, from this code repo, build a new image, push it to an image registry, and update our deployment. Basically, we want to build that pipeline. So if I go here in the pipelines directory, and we will see a pipeline here. Okay, so as Savita explained, a pipeline is nothing but a template with a task, right? There are multiple tasks. So if you see here, we have an array of tasks, so which we want to perform. There are parents. So pipeline is just a template. You can share with other people, and they can run it too. So we have multiple tasks. So we will see the first one, which is nothing but the Git clone. We want to clone the repo, right? So we are using a Git clone. So where this task is coming? So as Savita explained, we have a hub, right? So if you go here and search for Git clone, so you will find the task here. You can see the YAML, how it works. And if you want to install it, then you can just do this command. And in your pipeline, you just need to reference the task after you have installed. That's all. So tasks are like a template where you can pass params depending on your project. So so here we are passing the URL of the repo and like the revision means with the branch we want to clone. So this is like, that's all we need to do to use a existing task. Similarly, we have build and push for building the image, which are using builda. That is also from the hub. So we are just reusing that. One thing to notice is there is a run after. What that means. So we want to build the image only after we have cloned the repo, right? So we don't want to execute this task first. So we mention here, run this task after we have completed the repository successfully. If it fails, then this complete pipeline will fail. So yeah, and another thing to notice is the workspace. So let's say we have cloned the repo. So we need to access the code in this repo, right? So we need to build the image from that code. So workspace is nothing but a volume where you clone your repo, and that volume is shared between all the tasks. So this, if you notice here, so this workspace, it says output. So the fetch task, the Git clone task will clone the code and like clone it in this workspace, and this workspace will be used by the tasks which are in pipeline to execute their logic. So we have build and push, we have check deployment. So once we have built the image, push to a registry, now we want to create a deployment or update the deployment depending on what. So we first check the deployment, whether a deployment exists on the cluster. If it exists, then we will just update with a new image, like a new image which we have built. And if it doesn't here, we will create a deployment. So this is like, we had first thing is cloning, second is build and pushing to the registry, and third is creating a deployment or updating a deployment. And there are two more tasks which I will skip for now, but we will come back to it later. So here say, so I will just run this script. So this script is nothing but it will install the task, create a namespace, create secret, because we want to push our image to a registry, right? So we need authentication. So I will just execute this script, which will create some secret, some service account. So pipeline needs some access, right, to create the deployment or update deployment. So this script will create everything we require, and it will start a pipeline run. So pipeline is a template, and pipeline run is the instance of that pipeline running. So these are the parents which we will be passing to the pipeline, and that will be used to execute the pipeline. Okay, so let's see this in action. So I will just do pipeline run. So it is installing the task first, like we are using Git clone, builda, Kubernetes action for creating a deployment. So these two tasks are I am yet to explain, so I will explain them as we go. So we have created some secrets which are required and some RBAC. Okay, so the pipeline run should have started because we have started it manually. So So Tken, which is the CLI which is provided by Tekton, which interacts with the Tekton resources. So PR is nothing but pipeline run and LS like listing. So we can see that the pipeline has started. So this is the one of the way we can see or access our pipeline or task. Another is like the web view. So if we go to Tekton dashboard, which is also provided by Tekton CD, if we go here, Tekton, and we see the pipeline, right? So we can see the pipeline has started. The first was fetch, that is clone. So it is now building and pushing the image, right? So this will, once it's done, it will check the deployment, update deployment, and so on. So what we did here, right? Like we created our tasks which are required for a pipeline. We created some RBAC, and we then started a pipeline using the pipeline run. But this was like manually started, right? We can't do this every time. Every time we need to, we can't create a pipeline. So we need something automated, right? So whenever a code is updated in our Git repo, we want a pipeline to start it, right? So for that, we have Tekton triggers. So we can see everything is completed. It shows completed. If we go here, if we go, we can PR LS. It says the pipeline is succeeded. So it has updated the deployment. Okay, so this is the deployment for the application. So you can see it is like 44 seconds. So it is recently updated with the new image. And so now to set up triggers, first we will see our concepts, like what are the different concepts in triggers, and we will come back to the demo and set up like automated end-to-end triggers for that. So back to you, Savita.
Yeah, could you share the presentation, Shivam? Yeah, can you go to the trigger slide? Yep. Yeah. So we saw till now like how we set up the pipeline manually, but when we talk about the CI/CD, there should not be anything manual operation. I mean, what is CI/CD? It should be continuous integration, continuous deployment without the manual intervention. But the demo we saw is something we manually ran the pipeline. So that is something we don't want. So to avoid that kind of thing, we have another project which does some operation for us, which is Tekton triggers. Understand few of the core concepts trigger provide us today. So we have a event listener object. So it is kind of a custom resource which tries to run Kubernetes pod and Kubernetes service, and which keep on watching for the incoming HTTP request. And we have another custom resource called trigger. So this trigger basically decides what to do with the incoming event. And then we have an interceptor. It is again a continuous running pod which does some operations like validation of the bot, validation of the whether to know that whether the events are coming from the authorized sources or not. Then we have a trigger template. It is kind of a blue, actually contains the information of pipeline run, okay, or it could be task run. Then we have a trigger binding. So it is another custom resource which actually does some operation on the incoming request. So what it will do is like once after the validation is success, the data comes. So it takes the values from the incoming event and extract values from that request and pass it to some variables. And those values, or we can say those variables, will be used further inside a trigger template. And then we have a cluster trigger binding. It is similar to trigger binding but runs at the cluster level. Shiva, yeah. So we saw those are the different concepts, but I just want to show how they are interconnected with each other with the diagrammatical view. So as I said, like when I apply event listener YAML, it creates a pod and Kubernetes service for me, and that pod continuously watches for the incoming event. So you can see that a event is coming to the event listener pod. Once event comes to the event listener pod, trigger does some operations to what to do with that event. So what it will do, it will passes that event information to the interceptor. Interceptor does the validation, and once validation is success, it will pass the incoming request to this trigger binding. So what does this trigger binding do? As I explained, it will extract the data, or we can say body, from the event and do some operations and pass it to the variable, and those variables will be used inside trigger template. And as we discussed, trigger template contains the information of pipeline run. So my point here is the event information coming from the any of the sources like GitHub, Bitbucket, GitLab, that information will be finally passed to the trigger template where actual pipeline run or task run resides, right? And then finally it will create those resources. And right now, Tekton Trigger provides few of the core interceptors like GitHub, GitLab, Bitbucket, CL. These are the interceptor. I mean, these are the event sources where Trigger supports. But there is also one of the functionality of the Tekton Trigger is to write your own custom interceptor. I mean, you can add your own event source. You can run your own event source and integrate with the Tekton Trigger. And Tekton Trigger will easily use that one. This is how the Tekton trigger works. Now, I would like to take these concepts and explain how this Tekton trigger dynamically schedule those pipeline run which he has already written. Over to you.
Yeah. Sorry for that. Okay, so we ran a pipeline. Now let's see how to set up triggers. So we want to set up our triggers on this repo because we will be doing some code changes in this repo and the pipeline should have started, right? So let's go to the files and let's see what are the different resources. So if I go to triggers, so we can see an event listener here. So this is an event listener which will be watching for the event basically. So in this we have a binding and a template and an interceptor. So the interceptor is nothing but it will help you filter out the event. So for this demo, we will be using the push event. So let's say we configure a webhook for all the events, but we want to only like process only the push event. So we add a filter here, which would filter out the events basically. There are many more interceptor, GitLab, other. We can write our own interceptor also. The second thing, which is the binding. So if you see binding, so binding is nothing but, so the event which is coming from GitHub or any other event source will have some payload, right? So if we want to use some data from that payload, then we use binding. So we say that from the event which is coming, get the head commit, the URL, and the push strat, which is nothing but when the event was pushed. So we want to use this data in our pipeline somewhere. So we define our binding, and the last one is the trigger template. So this is where we define which resource to be created. Event came, event listener will listen the event, then it will, using the trigger binding, it will get that data from the payload, and then it will create the resource which is mentioned here, which is nothing but pipeline run. So in this pipeline run, we will say you need to start a pipeline, right? So you need to start this pipeline, and these are the params which you need to pass to it. So while creating the pipeline run, basically. So we saw event listener, which is watching the event, interceptor, which is filtering out the events, trigger binding, which will get some data from the event payload, and the template is nothing but what we want to create. So this only pipeline run and task run are currently supported, and a route. So we need to configure this event listener with GitHub, right? So we want something publicly accessible. So as it is an Openshift cluster, we are using route. But for any other cluster, you just need to create an ingress on this service and you will be fine. There's nothing extra. Okay, so I just wrote a script that will just execute this command. So let's see. So it should create all the resources, and okay, if we do kcd.live get pods, okay, there is an event listener pod which just came up, and if we do kcd.live get out, and we will get an event listener out. You just need to take this, and now we will go to our code repo, which is this one, news demo. So if we go to the settings, so we want to set up a webhook, right? So we'll just go to webhook, add a webhook. So we will add our URL here. We'll do JSON format. We just want to push event, and we will just say just add a webhook. So you will get a successful here. If your event listener is up and running, it will just ping it and just tell you this. Okay, so we have set up our triggers. We are ready to do any code changes. So to see whether the triggers is working or not, so I have a code. The code repo is generally like cloned here. So I will just do a no edit comment and just force push it. We just want to check whether the pipeline then will start it or not. We will do a code changes and do a end to end later. So for now, I will just do a force, like I will just create a push event. I will just force push to the main branch, and there should be our pipeline run started. Okay, let's see. Okay, something is wrong. So let's see our logs. If we go to our repo, which is here, if you see here, okay, something is failed. It says not found. Let me retry. Okay, this time it has succeeded. I don't know why, but it should have started a pipeline. Okay, so we can see a new pipeline. Basically, the previous event was not delivered due to some reason. And if we go to the dashboard, we will be seeing a new pipeline. So what I did was the event was unable to deliver, so I just re-delivered it. Ideally, this doesn't happen, but I don't know why it happened this time. So yeah, so we have set up a webhook. So whenever there is a new push event, so this event will be delivered to the event listener. The event listener will process the event, take some data from that payload, which is defined the binding, then add it to the pipeline run, because we have added here, right? You can see here, like add the Git repo URL, which is coming from the event, the revision, and then start this pipeline run. And this pipeline run we can see here, which is started. So which will execute all the things. So yeah, so this is how we can set up the end-to-end CI/CD. So we can see that this is also updating our dev instance. So currently the application which I deployed here, we are let's say call it as a dev instance, because we are going to set up another instance, and then we will integrate both ArgoCD and Tekton together. So this is nothing but a one instance where we have end-to-end CI/CD. Whenever some code changes are done, that will be built, a new image will be created, and the image will be updated on the instance. So this is like how you can set up the CI/CD using Tekton. Now we will see what is ArgoCD, and how then we will see why we want to integrate Tekton and ArgoCD together. What are the benefits? So back to you, Savita. Let's start with ArgoCD one.
Oh, sorry. Can you go to next slide? I was speaking on mute. Yeah, okay. So till now we saw how we can ensure end-to-end CI/CD with Tekton. Now let's understand ArgoCD and what is the use case of ArgoCD to use. Okay. So before that, ArgoCD is also a Kubernetes controller, which is something similar to like how we have Tekton. And it's a declarative GitOps continuous delivery tool for Kubernetes. And ArgoCD is used as a standalone tool, or it can be used as a CI/CD workflow. And the single source truth for the Argo is a Git repository where the Kubernetes manifest or Helm charts resides. And why should we use ArgoCD? So basically, ArgoCD will be helpful for the application deployment, lifecycle management, everything in a automated fashion. So if you want to understand the use case, why we want to go for Argo, why can't we just do with the Tekton? So as per my understanding, what is like if Argo CD will be very helpful if we want to do with the multi-cluster GitOps operations. So what is that? So let's take a scenario where I want to deploy 10 application like in a 5 clusters, and I can make use of any of the Jenkins, use any of the Helm or customize to deploy my application. And even I can do update also if there is any change in the image information or something else. But what so here what I need to do, I need to configure such a way that it should go I should go in a five different cluster and do the changes every time. But what if I have a 10,000s of application and thousands of clusters? In that case, it will be very difficult to do this stuff manually. There is a lot of chances like we may forget, we may tend to do some mistakes and all those stuffs. So here comes a GitOps operation, which is the best solution to solve this kind of multi-cluster operations. And we have a Argo, which does easily for us. Now, how Argo for us? Shivam, can you go to next slide, please? Yep. So here we can see that we Argo, similar to Tekton pipeline, Tekton trigger, Argo also have many custom resources. But as per our demo, we are just making use of application custom resource, and that's the reason we took this as an example to explain this topic. So basically, it's a custom resource definition which does which have two important concepts called destination and source. So basically, this application contains information of your destination cluster where the application should go and deploy, right? That as I said, like if you have a 10,000s of cluster, thousands of cluster, 10,000s of application. How Argo CD will get to know like where should go and deploy? So that is where a destination play important role. So here we will specify on which namespace and on which cluster I want to go and deploy my application. And then we have a source. I mean, if you want to deploy something, there should be some source, right? I mean, it could be Kubernetes manifest or it could be Helm charts, right? So to provide that information, we have a source, and this source contains KTest stage, which is nothing but the path of the Kubernetes manifest. And if you have a Helm charts, you can specify the chart name. And then we have a repo URL which is given down where you can specify where the URL of the GitHub repository where actually the data exists, or you can say manifest exists. So with this with the help of these applications here, we could able to achieve that work. And we have another concept of Argo called sync. Now, how Argo will get to know? Okay, changes happen in the repository. I mean, let's suppose I did some image change in my Get repository where Argo CD is watching. How Argo CD will get to know that okay, there is a change, I should get my cluster to be updated? How that happens? So there a sync process will come into a picture. So what it is tries to make always to make sure that the resource present in the Git repository and the resource present in the cluster should be in sync always. They should not be in sync. I mean, out of sync. And this thing we can do in two ways. It can be automatic or it can be manual. So most of the time we do prefer automatic, but there will be few scenarios where we will do manual because we want to make sure that before upgrading to my cluster, we want to make sure that the updated changes in the GitHub repository is proper or not. So to have that gap, we will configure as a manual sync so that administrator or end user, they can just verify that PR and then do manual sync. So this way, it depends on our use case entirely, which one we want to do. So this way we can able to make use of this sync this thing and try to make sure that the cluster state and the Git state is always in sync. So this is at the high level concept of Argo and why we need to use ArgoCD. Now I would like Shivam to take over from here and explain how we could able to integrate both Argo and Tekton and with the pipeline which he have deployed previously and how he could able to integrate with Argo. Yep, over to you, Shiva. Thank you.
Yeah. Yes. Thank you, Savita. So we saw that we have deployed an instance using Tekton, right? So let's deploy another instance using ArgoCD. Then we will like integrate both of them together and see how beneficial that would be. So Argo is quite big, so but we are using only one concept of it, that is the application CR, where we are telling you need to deploy this application, which is stored here, which is in a Git repo in a directory, and you just need to go and install that on our cluster. So okay, so I will show you the repo. So in this repo, there is a kcd stage, which is nothing but a staging configuration, and the dev is nothing but which we use for the other instance. So if I go to the cluster, if I do Argo, so I just have, so this script nothing but will create the, will apply the application CR of ArgoCD, and it will also create a config map, which will have an API key. So the application which we are using needs the API key, which is nothing but which we, so I don't want Argo to manage my configuration, which is maybe secret or config map. So I will create the config map myself, and I will just tell the ArgoCD, yeah, if you can just ignore this change to the config map because I will handle that myself. So you can do this for secrets or any other thing. Okay, so let's do this cluster and create the application CR. So it has created a config map with the API key which is required for the application to work, and it has created the application CR. So ArgoCD has a nice dashboard where you can see all the created resources. So as Savita mentioned, the sync policy, right? So currently our application is out of sync because it has not been deployed on the cluster, but it is in a Git repo, so it is expecting a synchronize. So there are two ways, like one is automatic or one is manual. So we have kept it manual for now. We will say now you can sync. It is like I am giving him permission to sync basically. So if we go to the cluster, if we do kubectl get pods, and we will see the another new stage namespace where the ArgoCD will deploy a new instance. So this is like we can see the pod. If we see the route here, okay, so we have a new route. If we go to the cluster browser, and so the application will be up. Okay, so this is our staging instance, and we have our dev instance, right? So the dev instance is deployed by Tekton CD end to end from the code, and the staging instance is just deployed by ArgoCD by watching over this manifest. So now, how do we integrate them both? Like, and what is the benefit? The benefit which we get from ArgoCD is like the transparency. We know that whatever is deployed on the cluster, it's coming from this. So whenever we change something here, ArgoCD will notice that and deploy it on the cluster. And the pipeline which we ran, which will have developed any new changes to our dev instance. Okay, so I will just show you a diagram. So this is our code repo, and this is our configuration repo. Just a sec. Okay, so we have set up an event list now, which is watching for events and which will start a pipeline. So everything is done. In our pipeline, we saw there were two extra tasks which I didn't explain before. Okay, so in our pipeline, we will go back to our pipeline and see the two tasks which I didn't explain before. So there was this one. So after building our image, we have a new image, right? So we want to create a pull request to our staging configuration. Why? We will see in a bit. So the two tasks were like it used to like create a pull request to our staging configuration with the updated image. And why it is created, we will see in the end-to-end demo. And yeah, so the last two tasks were for that. So let's see an end-to-end. So what we will do, we will do a code change. Then we will see our pipeline started. Then we will see the pull request created and the ArgoCD part. Okay, so let's go to our code. So if you notice here, we have news demo written, right? So we'll just do some small change here. News demo by Tekton and ArgoCD. I will just do a replace, and I'm just going to commit this change. I would say updated title. And I'm just going to push this change to the main branch and hoping pipeline would get the event. Okay, so new change is pushed. If we go to our code repo, which is here, and if we see here, new commit has pushed, right? And our pipeline should have started. Let's see. Okay, yeah. So this time the event listener got the event. Last time it may be a networking issue. So let's go to the dashboard. So Tekton dashboard, if you go to pipeline, then okay. So the new pipeline started with a new change, right? So this will get the new code, build a new image, and update our dev instance. So we'll see the changes there, and then okay, here we saw that we had the last two tasks. So this time we will see what they are. So let it finish. Till then, I will just go to the image. Okay, here. Okay, so how does it relate? We have event listener, we got the event, we started the pipeline, we cloned, built and pushed. We updated our dev instance, which is running here. And we created a pull request to our configuration repo with the updated image, which is watched by ArgoCD and which will nothing but handling our staging instance. So let's see. Okay, so the pipeline is completed, right? So if we go to our dev instance, which is in the news demo dev, and see, let's see the pod. Okay, this one, this is our application pod, which is started 35 seconds ago, right? So if we go to our, so we can see a change here, right? And this change is our dev instance. If we can notice this from the URL. If we go to our staging instance, there is no change. It's the old one. Okay, so in our pipeline, we created a pull request, right? So let's go to that. There it is. Okay. If we go into the, so this is the last task, which is creating pull request, and in the result, we have a pull request. So let's go to that. So this pull request is on our staging configuration. So what it is doing, it's changing the image. So why? So let's say we merge a pull request in our code, or we added some new code, and which is will deploy our dev instance, right? So now we have saw the changes, right? We saw the changes are good, and we want to these changes to apply on the staging configuration. So we can build the code and set up a pipeline. That too will work, but we already have an image which is working fine, and we will just go here and merge this pull request. So ArgoCD is already watching this, right? So it is nowhere to watch for. We have configured it for. So if we go to our ArgoCD and see, okay, it's say out of sync. Yeah, because the image is updated in our configuration. So it is saying that, so here you can see, this is a deployment, right? It's say out of sync because the image is updated. So now we have saw the changes here, that the changes are fine. So we can promote them to our staging instance. So if we go back to here, we'll just say, so this can be done automatically. For demo purpose, we just kept manually. So it will fetch the new image and update our deployment.
Yeah.
So we saw the changes has been applied. So I will just show the changes once and pretty much okay. So the image is updated on the staging instance, and we go here. Okay, so this is our staging, and the image is successful. So in short, so we saw that how end-to-end Tekton pipeline helped our dev instance, and how we use ArgoCD to manage other instances. So you will find all the code on this repo, it's Tekton-ArgoCD. You will find all the installation steps and explanation. If you feel any issue, you can just create an issue. We will help you out there. And please do try out and let me know your feedback. We'll be happy to help you. Thank you.
Thank you for the very informative talk for you and Savita.
Thank you.
Bye.